Hi, this is Bob Weller here to talk about quantum dissonance. The way I got interested in this, when I graduated from college in 1979, my wife and I, Ellen and I, were trying to find a way to measure the exact amount of dissonance in any 12 equal-tempered notes. We were surprised to find that there was nothing like that. There was no system for measuring the exact dissonance in any combination of notes. So we invented one. And after inventing it, we also found a hidden harmonic idiom in the Rite of Spring and other pieces by Stravinsky. And I wrote about that and did 5 videos on that in Stravinsky and Cubism, if you're interested. But today I'll be talking about quantum dissonance, which is sort of the first theory in the 80s, the early 80s, that I came across that helped me to unlock the harmonic idiom of the Rite. So what is quantum dissonance? Quantum dissonance is a way of measuring dissonance, and like I said, it reveals this harmonic structure. And there have been attempts to do it in the past. When I was researching this originally, there were 2 that stuck out to me, one by Paul Hindemith and the other by Vincent Persichetti. And the Hindemith system, and this would be example 1, the Hindemith system is fairly vague about higher levels of dissonance, like when we get past the point where tonality is no longer making sense as an explanation. It doesn't say much about that. Persichetti's system says a little bit more about it, but it's not complete. Neither system was totally adequate. I'll show you what I mean. In example 2 here, we have this chord, which is not a real dissonant chord, but a little bit dissonant. And then you can see here from the example 2, that what we do is we take every interval and add it. And the half steps count for 2, and the whole steps count for 1. And there's nothing, the tritone doesn't count for any kind of dissonant position. And then we add up the values at the bottom, and in this case we get 6 for the value of this original chord. So in example 3, you see where the problems start to come in. Let's take a look at example 3A, which is just basically a major scale, but all played simultaneously. It has a value of 8 in Persichetti's system, and here's the second example, B, which has a value of 6. So you can hear that the example B is quite a bit more dissonant. There's B, there's A, here's B. And if you're paying attention, you might say to yourself, well, that's because all these notes fit into C major, which is true, and that's part of the answer to this question. So to show you how quantum dissonance works, let's take a major triad, the C major triad, and we're going to add some half steps to it and see what happens. So here's one. We'll add the B natural. So we have here a C major 7, which is part of a major scale, C major scale. So that's pretty clear, no problem there. It has a tonal explanation. Same thing for this F. We add the F. There's a tonal explanation for that, C major. Let's add the F sharp. That would be C Lydian or G major. If we add the A flat, a little more dissonant, and it sort of fits into this, what we call an A flat Lydian augmented chord. It's the same chord as the ascending form of a melodic minor on F. For those of you that don't know about Lydian augmented, it's just one note different from the major scale. That's Lydian augmented on E flat. Here's C major. Lydian augmented on C looks like this. So we only use those 2 7-note scales, and also whole tone scales and octatonic scales, 8-tone scales, for this kind of analysis. So we've added all these half steps, and we've come up with basic tonal combinations. But what happens when we add the D flat? That's a little different thing, because when I fill in all the most consonant notes, this is part of the procedure of quantum dissonance, is we fill in the most consonant notes with the original chord. So that's the original chord. Now we're just going to find the most consonant combinations that we can. And what we come up with in the end gives us the measurement of the amount of dissonance. This chord, original chord, is what I call a first level chord, because it has basically no tonal explanation. It's just stepping over the line into atonality, and so it has no particular description. I mean, we could call it C major over D flat, like that, but we're starting to get, the terminology starts to get a little bit dense. It's the same thing with this E flat. It's going to be the same thing. We end up with an octatonic scale. And all I'm saying is that we just added all the most consonant notes that we could add to this chord. So we come up with this 8-tone octatonic scale. So that means that these chords, these two, are slightly more dissonant than these. And you can hear it. You can hear the difference. And that's the reason why, because it requires a more complex scale to explain the original chord. So what are the boundary here between tonality and atonality? I just mentioned that when I didn't get really, when I finished this in 1986, when I was living in New York, and kind of lost interest in it for a number of years. And the reason for my renewed interest was the fact that I was teaching my sons harmony, particularly my older son, and we talked about jazz harmony a lot, and we had an explanation, for example, something like this, you know, C minor 13, etc. But we had no real explanation for 20th century chords like this one, or the Rite of Spring chord, for example, or many others like this. So what happened was I just sort of naturally progressed into talking about quantum dissonance when we got past the point where the jazz terminology and the tonal combinations were no longer explaining what was going on. And what we eventually discovered was that at that point where tonality leaves off, a different kind of harmonic organization takes over, a harmonic organization that's based on a discrete level of harmonic tension, or in other words, a discrete level of dissonance. And this is what I found in Petrushka, and particularly in the Rite of Spring by Stravinsky, an organization that was based on this principle of discrete level of harmonic tension. So here's what I'm talking about. Let's say we have this chord. We'll call that E flat major 7 plus 5, and that's a part of E flat leading augmented, or C minor 7, or C minor, the ascending form with a major 7th. What happens if we drop this down to the G down to an F sharp? Now, in order to explain this chord, if we fill in all the most consonant notes, we end up with another 8-tone scale, which tells us that this is first level. This chord is first level. That happens to be a variation of the Rite of Spring chord. Anybody will recognize that, which is a combination of major and minor chords simultaneously, like parallel modality. That's a typical Rite of Spring chord. There are many incarnations of it, this and all kinds of stuff. But that's just an example of stepping over the line from tonality here to atonality here. That's the beginning, where you start to move into that other domain, that other harmonic idiom. Another example would be what they call the plus 9 chord, C7 plus 9 in this case. If you chart this out, if you look at it in terms of quantum dissonance, it's going to end up being another 8-tone scale, like that. But if we take the 5th out, it reduces the harmonic tension because we can fit it into this scale, which is a leading augmented scale based on E. So you can hear the slight change of tension. Here's without the G. Now here's with the G. Like you hear the harmonic tension goes up very slightly. So that's a brief explanation of quantum dissonance. The quantum part of it is the fact that the levels of dissonance in quantum dissonance change a lot like the electrons in the Bohr's model of the atom, Niels Bohr. They change by discrete steps. The electron shells move in discrete steps, and the electrons move from one level to the next without any intervening step. And so with quantum dissonance, we have 0 level, which is all the tonal chords. Then we have the first level, and then we have levels 1 through 5, which corresponds to the addition of 1 through 5 notes in the scale. So we finally, at level 5, we have all 12 notes. So that's an explanation of quantum dissonance, and in the next video I'm going to talk about the first appearance of the first level harmony that I've been talking about here, way before the rite of spring, in fact. So thank you. We'll see you in the next video.